ChemStars. You're welcome to Chem Farm with Goodness. So this is the completion of what we did previously. As you can see, part B. If you have not seen the previous video, please go ahead and see it, okay? You will get the foundation of what you are doing here. Now quickly, let's go back to what we have today for the relationship for ideal gas equation. We stated that T is the temperature in Kelvin and number of moles in mole, V volume in dmQ, pressure in atm, and we gave instances of how to apply this formula. And we also said there are cases where you will not be asked to calculate the number of moles, okay? These are the examples. We go ahead and see how to calculate some of these variables that are not moles. Beautiful. Now let's take the question for number 1. What volume would an ideal gas of 0.011 moles, which exerts a pressure of 2 atm at 8 degrees Celsius, occupy? Let's take the question again. What volume would an ideal gas of 0.011 moles, which exerts a pressure of 2 atm at 8 degrees Celsius, occupy? What volume? You have to get the volume now and not the number of moles. Okay, so let's go ahead and solve the solution for question number 1. Let's go ahead and write down our variables. We have gotten volume, unknown. This is for the n, number of moles, 0.11 moles. Good. What again? Which exerts a pressure of 2 atm. Our P comes in 2 atm at 8 degrees Celsius. Degree Celsius is talking about what? Temperature. But we are not going to solve with degrees Celsius. We go ahead and convert it to what? Good. Kelvin by adding 273. Very good. So we say 273. Which is equals to 281 Kelvin. So we have our R, which is our molar gas constant at 0.082 atm dmQ per Kelvin per mole. Alright, so we have gotten that and given variables and the unknown and also the constant. Now let's go ahead, write down this equation and substitute our given parameters. So PV is equals nRT. Beautiful. What is our P? Our P is 2. Okay. What is our V? Is unknown. So I will write V. Okay. Our N is what? Number of moles, which is 0.01. 0.11. What is our R? Our R is the molar gas constant, 0.082 times, and then our T, temperature in Kelvin, 281 Kelvin. Beautiful. What do we do here? You make V the subject of the formula. This is the one we are calculating. How do you make it the subject of the formula? Divide every other thing with the coefficient of V, which is what? 2. Beautiful. So we now say V is equals 0.11 times 0.082 times 281 divided by 2. Are you with your calculator? Bring it out and punch. This times this times this. We are going to have our V as 2.53462. And what is the unit there? dmQ. You can write it in 3 significant figures. 2.535 dmQ. Alright, so that is the answer. Let's quickly go over to question number 2. Calculate the pressure of an ideal gas of 2.0 moles, which occupies a volume of 21.32 dmQ at a temperature of 13 degrees Celsius. You can go ahead and pause this video right now. Try and attempt this question by yourself. Are you getting me? So you come back and let's see how we are going to solve it together. Alright, now let's go ahead and solve it together. Calculate the pressure of an ideal gas. That means we do not know our P. Beautiful. Of 2.0 moles. Our moles talks about N. Which occupies a volume of 21.32 V. dmQ. At a temperature of 13 degrees Celsius. So what do? Simply add your 273 to your 13. So that you'll be having what? 286 Kelvin. Quickly, let's write down the equation and substitute. Our P is not given. Our volume is what? 21.32, okay, equals what's our N? 2.0 times our R is the molar gas constant. It's always given. Please do not forget. 0.082 times our temperature, which is 286 Kelvin. Beautiful. Now you make P the subject of the formula. We have 2.0 times 0.082 times 286 divided by 21.32. Now go ahead, multiply all these things together. We'll be having 46.904 divided by 21.32. Now go ahead, punch your calculator and divide this. What will be our pressure in ATM? 2.2 ATM. Beautiful. That is the answer. As you have seen, we've been able to calculate for the first question our volume and for the second question our pressure. That is it. Now, thank you for seeing this video. I hope it's worth your time. Please feel free to comment, share, okay, invite your friends, tell them that Auntie Goodness is here. In ChemStars, we make chemistry fun, okay? Now, the follow-up questions posted in the comment section, go ahead and attempt them, snap and post. Let's learn together. And in case you have not subscribed, please go ahead and subscribe, be part of this family. This will boost it up in the algorithm, okay? At least to tell people that we are doing something. Alright, I'll see you in my next video. Thank you for seeing this video. I'm Goodness Ijeoma. Bye.